Assalamualaikum warahmatullahi wabarakatuh. A very good day to our beloved teacher, Madam Haslinda. So today, our group would like to present to you about queuing theory, waiting line model, and we are from JCS 143 5A. Before we continue to our presentation, I would like to introduce my team members. My team members consists of 4 people, which is Muhammad Farish bin Asalihan, Muhammad Haikal Aiman bin Azurin, Muhammad Iqbal bin Zainuddin, and the last one is Syazah Khalillah binti Ahmad Zairi. Without wasting any time, I would like to continue to our presentation. So, for this assessment, our group has choose Nakorn Tomyam, which is located at Segamat Central Shopping Centre, Jalan Kolam Air Kampung Gubah 85000, Segamat District Johor. This stall, operating hours for this stall is from 10 a.m. until 10 p.m. And our observation duration which from 8 p.m. until 9 p.m. This shop basically selling various type of drinks, and of course their main dish is selling various type of Thailand food. And mostly customer is consists of Malaysian people who live near to Segamat district.
Characteristic of queuing system. Next is the arrival characteristics. The size of calling population is unlimited, or in the other word is infinite. Patterns of arrival is random or unpredictable, which leads to Poisson distribution. And lastly, the behavior of arrival is patient and wait until being served. Next is the waiting line characteristics. The waiting line for our documentation is unlimited, and the queue discipline is first in, first out, which the customer who come first will be served first before moving on to the next customer. Service facility characteristic. Number of channels is multi-channel system, so S is equal to 2. Number of phases is multi-phases system, and lastly, the pattern of service is exponential distribution, so MU equal to 16 customer per hour.
Alright, so let's move on to another section. My name is Muhammad Haikal Aiman and I will explain about basic queuing system. So for our project, it will be multi-channel and multi-phase system. So what is this multi-channel? Multi-channel is like having a multiple server. So for our project, it will be 2 server. So when the customer arrive, they have to queue to order and payment at different server. They can order and pay at different counter. So after that, they have to queue again to pick up their order at the different counter also. So this is what we call multi-phase system. After all this phase, they can leave the system. Thank you.
Assalamualaikum and hi, my name is Muhammad bin Salihan, and we will do the calculation together. So let's assume S equal to 2 because we have 2 server, and lambda equal to 11 customer per hour, and the mu equal to 16 customer per hour. So the first thing we need to find, which is utilization factor, which is P, and the formula given is lambda divided by S times with mu, and we get 0.3438 customer. So after we get the P, we can find the P naught, and the final answer for P naught, which is 21 divided by 43, or 0.4884 customer. So after we get the P and the P naught, we can find the LQ, which is the average number of customer in the waiting line. So we just need to substitute the information given into the formula, and the final answer we will get 0.0921 customer. And after we get the LQ, we can find the average number of customer in the system. So after we substitute the LQ and mu and lambda, we get 0.7796 customer. And then after we get the L and LQ, we need to find the W and WQ, which is W is the average time spent by customer in the system, So with using the formula L over lambda, and we substitute the L and lambda, and the product is 0.709 hours or 4.25 minutes. And the WQ, which is the average time customers spend in the waiting line. So the formula given is LQ over lambda, and we substitute the LQ and the lambda. So the final answer we have 0.0084 hours or 0.50 minutes. So this is the result in QM. So in QM, we just need to substitute the lambda and the mu and the number of server, and we get the P naught, which is average server utilization 0.3438, and the average in the LQ we get 0.0921, and the L is average number is the system 0.7796, and the WQ, the average time in the queue, we get 0.0084, and the last one we get average time in the system, which is W 0.709. So that's all.
Alright, so right now for the conclusion of this project, so comment on the number of server provided and the customer waiting time. So the first question is the quantity of server offers sufficient? So our answer will be absolutely. It is because the customer service rate exceed their arrival rate. So the second question is, are customers satisfied with their wait time? So what we can conclude is yes. The answer will be yes, and people. This is because people will be satisfied since they won't have to wait around for too long to be served. And now explain the lesson that we have gained from the working on this project. So what we learn is when the mu more the lambda, there are enough server are available to serve client quickly. But if lambda is more than mu, then the server is unable to accommodate to many user, and it will influence the waiting time that will increase due to subpar service. Alright, that's all from our presentation. Thank you for watching. Bye.